A prominent symbol of Russian military power is the Su-35 fighter jet. The single-seat, twin-engine, heavyweight, super-maneuverable aircraft is designed by the Sukhoi Design Bureau. The type was originally developed by the Soviet Union from the Su-27. The aircraft has a top speed of Mach 2.25, and it can carry a variety of air-to-air and air-to-ground weapons. In January 2016, Russia made the first combat deployment of the Su-35 when it sent a fleet of 4 aircraft to Syria. Su-35 is considered to be the premier fighter jet in the Russian inventory since the Su-57 is not fully operational as of now. The fighter took years to build with lots of R&D going into it, and is touted by Russia as a 4++ generation fighter. Su-35 is currently being used in Ukraine. While Russia has tried to export the fighter to various countries, things haven't moved much. The only success was with China, which bought 24 of these, most likely because it had a special interest in the Su-35's engine. An Egyptian military official has now revealed to Special Defense that Cairo's decision not to finalize the deal with Russian Su-35 fighters came on the basis of a thorough technical study that showed several shortcomings in the fighter that are not in line with the requirements of the Egyptian Air Force and the nature of modern threats. In this video, Defense Updates analyzes how the Russian Su-35 got exposed by Egypt. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. In 2018, Egypt signed a deal with Russia to buy 24 Su-35 jets for about $2 billion, aiming to enhance its air defense capabilities with advanced technology. Reports indicate the first 5 jets were delivered in 2021, but the deal faced challenges, leading to its cancellation by 2020. The source confirmed that Egypt will not reconsider the deal in the future unless there are complete and radical adjustments to the fighter at several levels: radar, engine, operation, and armament systems. Post-cancellation, Egypt has pursued options like the French Dassault Rafale, ordering 30 units, and is considering upgrading F-16s or exploring Chinese jets like the J-10C, reflecting a strategy to diversify suppliers and address regional threats. Let's now check the technical shortcomings that have been pointed out. The Egyptian official stated that, despite being good in range, the Su-35's cyber warfare system is very weak in resisting disturbance and is easily deceived, citing that this is a major downside in the modern combat environment that relies on control and information sovereignty. It struggles to counter modern electronic countermeasures, such as digital radio frequency, memory, DRFM, jamming, making it vulnerable to enemy defenses. Its radar warning receiver, RWR, and countermeasure systems are not as advanced as those in Western jets. The lack of advanced sensor fusion, where data from radar, infrared search and track, IRST, and other sensors are not fully integrated, further hampers its situational awareness in response to electronic threats. The Egyptian official added that the fighter was based on a PISA-type radar, while the Egyptian Air Force was demanding a new generation ESA radar. Viewers may note that the Sukhoi Su-35 has IRBIS-E, a PISA, passive electronically scanned array radar. ESA, active electronically scanned array radar, has many advantages, such as being able to track multiple targets or perform multiple functions at once, while PISA is restricted to sequential scanning. Further, ESA's ability to change frequencies rapidly makes it harder to jam compared to PISA, which operates at fixed frequencies. The IRBIS-E's smaller bandwidth and inferior synthetic aperture radar resolution make it susceptible to jamming. The military aviation author, historian, and journalist Tom Cooper had stated that reports indicate that Egyptians ran a test, apparently using the first 2 to 3 Su-35s delivered to Egypt against their Rafales, and it turned out the Su-35's PISA is simply no match. Although Russia has introduced an upgraded model, it still falls short of meeting essential performance standards, whether in detection capability, resistance to jamming, or the quality of materials used. A significant limitation stems from its reliance on gallium arsenide, which suffers from poor thermal stability and high energy consumption. In contrast, modern Western radars use gallium nitride, a more advanced material that offers superior efficiency and thermal resilience. As a result, the system's performance is compromised, diminishing its competitiveness against Western counterparts in the same class. Radar is like the eyes of a combat aircraft, and an underpowered radar impacts its effectiveness to a large extent. The source further noted that the fighter cannot effectively conduct independent missions without support from command and control aircraft, AWACS. This reliance limits its operational effectiveness in the absence of such platforms, an approach that runs counter to Egypt's combat doctrine, which emphasizes autonomous mission readiness. The official pointed out that the engine used in the Su-35 has not undergone any real development, emits a very high sonic and thermal imprint, and consumes large amounts of fuel, which directly affects range, load, and disguise ability, especially if compared to fighter engines like the F-15. The Su-35 is powered by two Saturn AL-41 F1S turbofan engines, known for their thrust vectoring capabilities, enabling super-maneuverability and supercruise above Mach 1.1 without afterburners. These engines produce significant thrust, with 86.3 kilonewtons dry and up to 142.2 kilonewtons with afterburner. But their design focuses on performance rather than reducing detectability. The sonic imprint, or noise signature, is likely high due to the engine's operation, especially at high speeds. This noise can make the aircraft more detectable by acoustic sensors, particularly in close proximity. The thermal imprint, or heat signature, is also likely high as the engines operate at elevated temperatures, with the AL-41F1S having a turbine inlet temperature increased by 250 degrees Celsius over its predecessor. Unlike stealth aircraft, the Su-35 lacks advanced cooling measures like exhaust dilution with bypass air, which is used in the F-35 to reduce thermal signature. Ceramic coatings on engine parts used since 2008 may help manage heat, but it's still pretty high. This renders the fighter vulnerable to IRST sensors and missiles with an IR seeker. It is interesting to note that Ukraine has effectively neutralized around 7 to 8 Su-35s, though the aircraft have been used cautiously by Russia.